So chemical engineering at its most fundamental level is really this beautiful combination of obviously chemistry and math, but also physics and biology and computer science and electricity kind of all jumbled into one, which is really cool because you get a taste of everything. And maybe most importantly, it's about creativity too. Most of the problems we work with require creative solutions. And these problems could be designing process equipment and how it works, or maybe how a bunch of process equipment comes together. You might even be optimizing the process within that equipment, changing input variables to get a more efficient output. And the way that chemical engineering manifests in the real world is extremely vast. You could work on microscopic disease detection systems in a lab, or even all the way up to a $10 billion chemical plant or refinery, and everything in between. If you want to go into food processing, you could make Pop-Tarts or chocolate. You could work on manufacturing makeup or semiconductors. And another growing industry for chemical engineering right now is alternative energy. So that means anything like solar or wind power or geothermal, biofuels, even nuclear energy. So it's great to see things moving that way. So this right here is our small-scale model of both a gas absorber and a gas stripper. And ours just has water in it and a pH indicator, so that's why it's colored. But what this is modeling appears in industry all the time, especially in big chemical plants and refineries usually. And they're going to normally be about 50 times as big as this, if not bigger. And to show you how it works, I'm going to take a straw and just attach it to one of these little nozzles right here and open the valve respective to the hose. And what I'm going to do is blow into the straw, quite hard actually, and I'm going to exhale carbon dioxide. That carbon dioxide is going to flow into the column and be absorbed by the water, so that's our gas absorption part. As it's absorbed, there's going to be a reaction that takes place which creates carbonic acid. Since the solution is going to be acidic after that reaction, our pH indicator is going to change to a lighter orange color. So now that our water has absorbed some carbon dioxide and changed to a lighter color, I can actually reverse the chemical reaction by pumping air through the water. And this is our gas stripping part. So as I pump air through the water, it's going to neutralize the system and change the color back to its original red. So to do that, I'm just going to close the valve again and turn on a pump right here. And now we're going to see that revert to its original red color as the reaction is reversed. In industry, there are lots of carbon emissions which are harmful for the environment. And using a process similar to this in our model right here, called carbon capture, we can actually take some of these carbon emissions, store them somewhere else to reduce overall emissions.